So cos squared theta plus sine squared theta gives 1. This is one identity that you want to have up your sleeve. Means if I'm doing some problem in the future and I see 1, I can represent 1 with that. Or if I see this, I can represent it as 1 if I want, depending on what I'm doing. So when we're talking about having identities, you're talking about being able to substitute one idea for the other, depending on where you are and how mature the thing is. We are saying we can manipulate this and create 2 more. So let's think about creating from this. Let us say I keep the cosine theta by itself. Is the same thing as 1 minus sine squared theta.
Would it be sine squared theta equal 1 minus cos squared theta?
Exactly. So you can create them, thing like that. This cos 2 theta. Cos 2 theta could have come from cos theta plus the same theta. The same. Because since I said cos 2 theta, I can see it as cos theta plus theta. I am manipulating the sum formula because I can now say, oh, but this can be represented as cos theta minus sine theta sine theta. You remember now? I am getting cos square theta minus sine square theta here. This is a different thing. And this is a representation for cos 2 theta. 2 theta is equal to cos square theta minus sine square theta. Remember, this is all about manipulation. Now, I want to know if I can find more formulas for this. Recall this. I want you to recall. I want you to recall that cos square theta is 1 minus sine square theta. You can recall it. I'm going to point at it. Bam. Can recall it from that right there. We want to agree that, yes, I can recall that cos squared theta is the same thing as 1 minus sine squared theta. So because I am aware of this fact, I can now say that cos 2 theta can now be represented as, let's do the substitution now, man. You have to do the substitution. We're going to put 1 minus sine squared theta for the cos, yes. And then behind it, it was actually 1. How does that look to you? So I substitute this for that. And then I simplify that. So if I simplify this, look what I have. I have 1 minus, not 1 sine squared theta, but it's 2 of them now. 2 sine squared theta. We have 1 for your double angle, another 1 for your double angle. 2 things for your double angle. So in other words then, if I see cos 2 theta, I can represent it as cos squared theta minus sine squared theta. Or I can represent it as 1 minus 2 sine squared theta for that same cos 2 theta. This is the one that has a lot. So I can do one more. So I'm going to say recall. When I put the recall, you should know what I'm going to do. Recall that sine, I want you to recall that sine square theta is 1 minus cos square theta. You were the one that kind of put it beside. Cos 2 theta can also be represented as, I'm going to put this where the sign is. So I have cos square theta minus, And now instead of writing sine square around there, I'm going to put 1 minus cos squared theta around there. And then I'm going to simplify this. That negative sign is why when I see that negative sign, I'm not just going to write this without a bracket because this is a binomial. It's a double thing. So it means then that the negative sign will change both. So you'll get a -1 now and a positive cos squared theta. So if you put it together, look what you have. 2 cos squared theta minus 1. That is the same thing as cos 2 theta, right? So in other words, then we have now found a third. We have now found a third identity for cos 2 theta, right? So we have found a third one for cos 2 theta. What I was suggesting here was you could start it off by saying sine theta plus the same theta. So you could say that is sine 2. And this really means sine theta cos theta plus cos theta sine theta. That's what it means for the sum. And if you really look at it, it's actually 2 of it. 2 of the same thing. This one is only one identity I have for it. So 2 theta can be represented as tangent theta plus that. So you're going to have tan theta plus tan theta on top over 1 minus tan theta times tan theta. That is how we represent them. So at the end of the day, now, if you put it together on top, you'll have 2 tan theta, 1 minus tan square